Hello everyone, this is Yang Yang. I'm a software engineer from the cloud team of StreamNative. Today, I'm proud and excited to present StreamNative Cloud, a newly launched platform that offers Apache Pulsar as a service. You may have heard that there are more and more Pulsar adoptions across the world. People love Pulsar for various kinds of reasons. For example, Pulsar is blazing fast. According to our benchmark, Pulsar could achieve a high throughput and a predictable low latency even with durability when there are tens of thousands of topics and partitions in the cluster. It outperforms other messaging systems significantly. You could check the benchmark report on our official website for more details. Pulsar also has incredible elasticity. Whenever you scale out the cluster, it could allocate workloads to new nodes without waiting for the rebalance of the existing data. And as a cloud-native distributed messaging and streaming platform, Pulsar has a complete state-of-the-art feature set. It includes multi-tenancy, geo-replication, tiered storage, and so on. All these features are important for large-scale, high-available production-grade deployments. And Pulsar also has a booming ecosystem. You can find many Pulsar I/O connectors, protocol handlers, and offloaders on StreamNative Hub, which makes it easy to connect Pulsar to external systems and do computations and transformations on the data in Pulsar. And Pulsar offers all these for free as an open source software. But I have to say, it's still non-trivial to deploy a production-grade Pulsar cluster and fully unleash its power in an on-premise environment. It's because although Pulsar is great, it is also very complicated. As a distributed storage system, it's challenging to set up, scale, and manage a production-grade Pulsar cluster in the on-premise environment. Actually, when we talk about a Pulsar cluster, we are talking about a distributed system which is comprised of multiple components, including Pulsar brokers, Pulsar proxies, bookies, zookeepers, and even more. And when establishing the on-premise infrastructure to run a Pulsar cluster, you'll need to provision machines and configure these components. Design the cluster of distributed machines to ensure availability. Then you have to maintain the infrastructure, replacing machines when they fail, and doing routine patching and upgrading of the environment and the Pulsar stack. You also need to reserve resources for further scaling out the cluster, which will cost a certain amount of your budget. Also, setting up a cluster is not simply starting to run all the process. It also requires all the components in the cluster are configured with best practice, because cost-effective high performance requires optimal configurations of every component in the cluster. This configuration includes the hardware and the software configurations like CPU cost, memory size, disk type and size, network setup, OS version, system parameters, and so on. Needless to say, the configuration of the Pulsar stack, which includes tons of configurable items. And the optimal configurations could be different for different components. Moreover, the optimal configuration evolves with the new Pulsar versions and the new hardware and software. And if the cluster is not configured with the optimal configuration, you may not be able to get the best performance out of the cluster. For example, a couple of months ago, another messaging vendor published an inaccurate benchmark, declaring that their messaging systems had a better performance than Pulsar. We reviewed their report and found there were quite a few issues in their setup of the Pulsar. And after fixing all these issues, we did another benchmark, and our benchmark showed that Pulsar outperformed their messaging systems significantly. Because they may be experts of their messaging systems, but they may not know how to configure Pulsar clusters in an optimal way, unless they just don't want to do that. And keeping data secure throughout its lifecycle is also non-trivial. You have to enable TLS to protect communications between the clients and the cluster. And you have to enable authentication and authorization to prevent unauthorized accesses to your Pulsar cluster. You also need to set up firewalls to prevent the unexpected access from to your components in the cluster. You may also want to enable end-to-end encryptions for your messages. All of these setups requires help from security experts. Otherwise, you may do it incorrectly, and you may not be able to protect your data in the cluster. Furthermore, a production-grade Pulsar cluster is not only Pulsar itself. You will need advanced tools to manage resources in cluster and discover and analyze clusters status and instance in time. For example, you may need to set up Vault to keep secrets, to set up Pulsar Manager to check and manage cluster data, metadata, and status. You may also want to set up Loki, Grafana, and Prometheus for cluster metrics and logs, and the Alert Manager to send alerts based on a set of predefined rules. Then, you may have large volumes of data flowing into Pulsar all the time. You may want to employ tiered storage to offload the cold storage from bookkeepers in your cluster to cheaper storage mechanisms for long-term storage to save cost. And this kind of storage may not be available in an on-premise environment because it is not easy to maintain, but it's widely accessible on the public cloud, just like AWS S3 and Google Cloud Storage. Also, you may want to run Flink or Spark on the data in your Pulsar clusters to do analytics. Rather than deploying your own data processing engine, it may be more convenient to start a managed data processing engine instantly on the cloud. And actually, I have to say that this kind of complexity exists not only in Pulsar, but also in most of large-scale distributed infrastructures. So to sum up, we believe if you want to run a production-grade Pulsar cluster efficiently, you had better let experts to tackle all these complexities. And if you want to fully unleash the power of Pulsar cluster and make best use of your data, you had better run Pulsar clusters on public clouds. And based on this conclusion, we have developed the StreamNative Cloud, which offers fully managed Apache Pulsar as a service. On StreamNative Cloud, you can hand over all the operations and maintenance to us, so your team could focus on your business and reduce your total cost of ownership. The cloud offers production-grade managed Pulsar services, finely tuned by original Pulsar developers, so don't need to compromise on security or performance. The offered Pulsar service works just like the open source Pulsar clusters, and you can access with all the existing Pulsar clients or tools, so there will be no vendor lock-in. And we'll keep improving the platform and keep your Pulsar clusters up to date. And cloud customers could get 24/7 expert support by us because we have core developers from multiple time zones across the world. And the StreamNative Cloud is built on top of the Kubernetes. Kubernetes is widely supported by multiple cloud providers. And it serves as a foundation for the cloud native society. And the StreamNative Cloud itself also has a good multi-cloud support. Currently, the StreamNative Cloud is available on Google Cloud and Alibaba Cloud, and we plan to support more cloud providers soon in the future. Next, I will give you a quick tour on how to create and use Pulsar services on StreamNative Cloud. We offer multiple ways to access and manage resources on the cloud. But let's start with the Cloud Console, where you can create and manage Pulsar services with simple clicks. We deployed separate sites for China and the global regions. You can choose the China site if you want to deploy clusters within China regions, and choose the global site otherwise. And both these sites has multiple language support for Chinese and English. One thing to notice is that we have two types of clusters, the free cluster and the standard cluster. The free cluster is a good starting point to get familiar with Pulsar and the StreamNative Cloud, but it also has many limitations. On the other hand, the standard cluster is good for daily tests and production usages. Currently, the China site only supports free cluster for now, and will release the support of standard clusters in China site in the future. Then, let me give you a walkthrough of creation of a standard cluster on the global site. The workflow to create free clusters on China site is similar. You can click the link of the site, and you will land on the welcome page, where you can sign up either with a valid email address or with a Google account, whichever you like. You can also sign up with a GitHub account on the China site because Google is not accessible in China, and we will also support the GitHub login in the global site in the future. After you sign in, you need to first create an organization. Organization is a logical container for cloud resources. You can use organizations to organize your Pulsar services and resources by teams. You can create multiple organizations and invite your team members to join your organizations. You can also be invited to organizations created by others. And all organization members could manage and access all resources within the organization. You can see all the organizations you belongs to in the organization list. And one thing to notice that is the name of the organization should be globally unique. It's simple to create an organization. You can see it from the video. You just need to click the create button and pick a unique name for the organization and submit your request and wait for a short time. You may notice that there is some constraints in the name of the organization. Next, we can create an instance, which is a logical construct to configure a group of geo-replicated clusters. We should also first pick up a name for the instance. The name of the instance should be unique among all the instances within its organization. Then we can choose the cloud provider to provision the instance in. Currently, we only have the Google Cloud provider in the global site, and there are more clouders, or there will be more cloud providers available in the future. And then you should choose the cluster type. Cluster type determines the feature, usage limits, and price of your Pulsar services. Currently, you can choose between free and standard on the global site. As I have just said, free cluster may be a good start point for you to get familiar with Pulsar, but it has very low usage limits and there is no SA promises. And free clusters are subject to deletion after 30 days of inactivity. So we recommend you to choose the standard type for daily and production usages. Then you can choose, here we choose the standard type for demo. Then you can choose the availability of your Pulsar service between single AZ and multi-AZ. Single AZ could be more cost effective because there's no cross-zone traffic needed. But for a production cluster, you may want to choose multi-AZ because it has better resilience for zonal outages. Here we choose multi-AZ for our instance. Next, we can create the button to create the instance. And because we choose the standard, because we choose the standard instance type, we have to enter a valid credit card number to continue. And after a few seconds, your Pulsar instance should be ready. Next, we can create Pulsar clusters in the instance. Currently, we can only create one cluster in each instance. Well, actually, instance is a concept to model a group of geo-replicated clusters. It is a feature still in progress. When this feature is available, you will be able to create multiple clusters of the same instance in different regions. And all these clusters will be geo-replicated. And before we actually create a cluster, Please let me give you a brief explanation of the billing system. We use a usage-based pay-as-you-go billing model. For each Pulsar service, we'll charge you by amount of data produced and consumed in each billing cycle. And the storage and computation resources the service used up per minute accumulated in each billing cycle as well. The billing cycle is 1 month, which means the payment for each cluster will be collected at the end of each month since the creation of the service. And we are using a trusted third-party billing provider, and we don't keep your pay methods in your system, in our system. And next, we can create a cluster. The cluster works just like the open source Apache Pulsar cluster, and it is compatible with existing Pulsar clients and tools. There is an embedded Pulsar manager in Cloud Console, so you can manage the cluster easily. For the security, it has built-in support for TLS communication, OAuth2 authentication, and end-to-end encryption. To create a cluster, we also need to first specify the cluster name, which should be unique among all clusters within its organization. Then you can choose the region from the list to provision your cluster in. You may also request for a new region if it is not in the list, and will evaluate your request and make a plan. Then you can choose the number and the specification of the broker and the booking nodes. You will see the cluster cost and the capability changes shown on the right side of the page. We have experts tuned these parameters finely for all these specifications, and you can choose depends on your needs. A tiny cluster might be sufficient for development and tests, where a medium and our large cluster is preferred for some serious workloads in production. And finally, you can click the button to create the cluster. Your cluster will be ready. Well, after a few minutes, which is a fully managed Pulsar service, you can see the endpoints of the service on the page. In order to access the service with clients and external tools, you will need to create a service account. Service accounts contain keys that can be used with the Pulsar OAuth2 clients, or you can generate a token for usage if the clients you use doesn't support OAuth2. It could be either the service account could either be a super domain or not. If the service account you create is not a super domain, after you have created your service account, it won't have any access yet and must be authorized by granting the service account's role permissions to a namespace or tenant. And after the service account has been created, you can either download the key file or generate a token directly. With the key file and the token, you can visit the client's page to see how to connect to the service with their desired clients and CLI tools. You can also play around with these pages in the navigation bar on the left side for cluster management. So now we have created a fully managed cluster. Besides the Cloud Console, we'll also provide a CLI tool. We also provide a CLI tool called snctl to manage cloud resources in command line and scripts. Currently, it supports all CRUD operations of Pulsar instances, Pulsar clusters, and service accounts. You can see detailed instructions to the tools on our official document sites. We also provide a set of Kubernetes style RESTful declarative APIs to support API-driven operations as well. You can manage cloud resources programmatically with these APIs. And we plan to integrate the cloud with infrastructures as code solutions, just like Terraform and Plumi. So that's the end of our quick tour. You may find more information on our official StreamNative document site, and you can see the video of how to create clusters on StreamNative Cloud in both Chinese and English. Then I would like to introduce a couple of important works that are still in progress. The first is to support geo-replication. It is a very important feature that's requested by many customers. As you know, regional level disaster in a cloud provider is not rare in these days. And with geo-replication, you will be able to survive regional disasters. And we are going to support creating clusters of the same instance at different regions and configure them to be geo-replicated automatically. The cluster data will be replicated across regions asynchronously. Tiered storage is another important feature we are working on. The idea of the tiered storage is to move older messages in the backlog from Bookkeeper to a cheaper storage mechanisms, while still allowing clients to access the backlog as if nothing had changed. This is made possible by the data segment design of Pulsar. As once a segment is sealed in Bookkeeper, it becomes immutable and can be copied to long-term storage. The original data will then be deleted from Bookkeeper after a configured delay to release the storage space. It may save cost significantly for your long-term code data, and it's a common approach to backup data from Pulsar. Flink is a cutting-edge data processing engine that can be used to do both streaming and batch computation. Both Pulsar and Flink share a similar view on how the data and the computation level of an application can be streaming first, with batch as a special case of streaming. Pulsar developers has done a lot to integrate between Pulsar and Flink to provide an elastic data processing at message scale. And we are working on the integration between the managed Pulsar and managed Flink to provide a out-of-the-box streaming-first unified data processing solution. We believe it would increase the value of the data as the data can be processed easily and efficiently. And with data already published into the managed Pulsar service, it would be very convenient for customers to be able to run managed Flink computation on the data in Pulsar directly. We have also planned many important features to support in the future, like VPC peering, various protocol handlers, Pulsar functions, and so on. The goal is to support all the Pulsar features you can use in our Pulsar Cloud. To conclude, what StreamNative Cloud offers you includes various ways to manage resources. So you can provision a production-grade cluster tuned by experts within a short time. The cluster is charged by usages under a pay-as-you-go model. So you only need to pay for what you have actually used. We provide 24/7 expert support for cloud users, and there are multiple advanced features coming on the way. And the goal of StreamNative Cloud is to make Pulsar available everywhere. And we have already supported Google Cloud and Alibaba Cloud. The support of other cloud providers, including AWS and Azure, are also coming soon. And you can find more information on the official StreamNative websites. And you may, if you are interested, you can contact us for cloud support plans. And you can check the latest news from StreamNative blogs. Okay, that's all. Thanks.